Every year, construction and demolition waste fills landfills with over 2.8 billion tons of material worldwide. Bricks, timber, steel, glass. Most of it is buried or burned. But what if the waste was actually the most valuable thing on the site? Reclaimed materials are building components salvaged from old structures before or after demolition. We're talking about old-growth timber from century-old barns and warehouses, brick pulled from 19th century factories, steel beams from decommissioned bridges, antique tile, slate, and stone from demolished civic buildings. These aren't scraps, they're materials built to last generations, and they already have. And the range is wider than most people realize. Reclaimed cobblestones from the 18th century streets, cast iron columns from Victorian-era industrial buildings, hand-split slate roofing pulled from demolished schools and churches, antique hardwood salvaged from factory floors and mill buildings. Each of these materials has a provenance, a history, and a second life waiting. This is not a new idea. It's actually one of the oldest practices in building history. The Romans had a name for it: spolia, the practice of dismantling older structures and incorporating their materials into new ones. The Arch of Constantine, built in 315 AD, is assembled largely from components taken from earlier monuments. Medieval builders across Europe routinely dismantled Roman temples and aqueducts, hauling stone across generations to raise cathedrals. Before the industrial era, transporting or manufacturing new materials was so expensive and labor-intensive that reuse wasn't a choice, it was the default. What we now call sustainability was once just called common sense. We've spent about 150 years unlearning that lesson. What's happening now is a return to it at scale with the data to prove why it matters. Here's the environmental math that most people miss. Producing new materials is enormously energy intensive. Firing a single brick requires over 1,000 degrees Celsius of heat. Milling fresh lumber strips forests that took decades to grow. Smelting new steel releases roughly 1.85 tons of CO2 per ton of metal. When you reclaim instead of replace, you skip all of that. No new extraction, no new manufacturing, no new shipping from halfway around the world. Studies show that using reclaimed wood instead of new timber can reduce embodied carbon by up to 90%. That's not a marginal improvement, that's a transformation. But to understand why that number is so significant, you need to understand what embodied carbon actually is and why it's become the central issue in sustainable construction. Most people think about a building's energy use during operation. The electricity for heating, cooling, lighting, that's operational carbon. We've made real progress reducing it through insulation, efficient systems, and renewable energy. But there's another category that's received far less attention: embodied carbon. The CO2 released in the extraction, manufacturing, and transportation of building materials before a single occupant ever walks through the door. For a typical new building, embodied carbon can count for 50% or more of its total lifetime carbon footprint. The construction sector as a whole accounts for roughly 37% of global CO2 emissions when you include both operational and embodied sources. Meeting the targets set by the Paris Agreement, limiting warming to 1.5 degrees Celsius is mathematically impossible without addressing how we source building materials. Reclaimed materials don't just help. In many cases, they're the most powerful single lever available. There's also the quality argument that surprises most people. Old-growth timber, the kind harvested before industrial logging, grew slowly. Slowly grown wood has a tighter growth rings, which means denser, harder, more dimensionally stable lumber. You simply cannot buy this at a lumber yard today. Those forests are gone. The same is true for handmade brick. Pre-industrial bricks were fired longer at more variable temperatures, producing a surface character and hardness that modern machine-made brick can't replicate. Reclaimed heart pine, salvaged from the floors and beams of 19th century southern factories, is so resin-saturated that it's essentially impervious to insects and decay. Contemporary pine grown fast on managed plantations has none of that density. The biology is different. Reclaimed steel is another case. Once steel has been smelted, alloyed, and formed, remelting it for new use requires dramatically less energy than processing virgin ore. Scrap steel recycling uses approximately 75% less energy than primary production. The material has already done the hard work of being refined. Reclaimed materials aren't the lesser option. In many ways, they are the better one. And then there's what these materials do for a space. There's a reason designers and architects actively seek out reclaimed materials. Age gives materials something new ones can't fake: authenticity. The patina on a 150-year-old beam, the uneven surface of hand-laid cobblestone, the color depth of oxidized copper, the shadow lines in a wall of antique brick where each unit was shaped by a human hand rather than a machine. These details tell a story, and in a world saturated with mass-produced interiors, a room built with reclaimed materials stands apart the moment you walk in. There's a psychological dimension to this too. Research in environmental psychology consistently shows that people feel more connected to spaces with material texture, variation, and evidence of age and craft. New construction materials, precise, uniform, engineered, can be technically superior in specification while being experientially flat. The imperfections are the point. To understand how reclaimed materials actually enter the supply chain, it helps to understand the difference between demolition and deconstruction. Demolition is fast. A structure is torn down mechanically. Excavators, wrecking balls, implosion, and the resulting mixed rubble is hauled to a landfill or, at best, partially crushed for low-grade fill. Deconstruction is different. It's the systematic, manual disassembly of a building, component by component, in reverse order of construction. It's slower, it requires skilled labor, but it can divert 70 to 90% of a building's materials from landfill. Flooring comes up intact, windows are removed whole, brick is carefully separated from mortar, timber is pulled, inspected, and graded. Several cities in the United States, Portland, Oregon being the most prominent example, now require deconstruction rather than demolition for older residential buildings. The policy logic is straightforward. These older structures contain materials that can't be replicated, and once they're crushed, they're gone. The Life Cycle Building Center in Atlanta, the Reuse People in Oakland, the Renovation Angel Network. These are organizations building the professional infrastructure around deconstruction, training workers and creating the supply chains that connect salvaged material to active projects. The proof of concept exists at every scale. The Bullitt Center in Seattle, often called the greenest commercial building in the world, incorporated reclaimed and salvaged materials as a part of a broader commitment to radical embodied carbon reduction. The High Line in New York repurposed an abandoned elevated railway, preserving its original steel structure and reusing the historic rail tracks as design elements throughout the park. What could have been scrapped became one of the most visited public spaces in the world. In the United Kingdom, reclaimed Victorian brick, particularly London stock brick from demolished East End warehouses, commands a significant price premium over new bricks, precisely because of its color range and surface character. The salvage market there is mature, sophisticated, and deeply integrated into the design community. At the residential scale, a farmhouse renovation in rural Pennsylvania might source hand-hewn chestnut beams from a collapsed 19th century barn. A Brooklyn brownstone gut renovation might specify reclaimed wide plank white oak floors from a demolished New England mill. A wine bar in Portland might sheathe its walls in corrugated steel pulled from a decommissioned agricultural buildings 2 countries over. These decisions are happening constantly across every building type on budget level. The question is whether they're treated as an afterthought or a starting point. Now, reclaimed materials aren't without challenges, and this wouldn't be an honest conversation without acknowledging them. Sourcing takes more effort than ordering from a catalog. Supply is inherently variable. You can't always get 100 of anything in exactly the same size. You need to verify structural integrity, especially for load-bearing timber or steel. Lead paint and asbestos are real concerns in materials from buildings constructed before the mid-20th century, and remediation adds cost and handling requirements. Dimensional variability can complicate installation. Reclaimed hardwood floors, for example, often require more careful subfloor preparation and longer acclimation periods. These are real constraints. They require more planning, more lead time, and experienced contractors who know how to handle and work with the materials that don't come with a spec sheet. But for most projects, the extra effort pays back in lower embodied carbon, in material character, and often in cost savings when compared to premium new materials. Salvaged antique hardwood flooring, if you can source it, is frequently cost competitive with high-end new material, and in many cases, it's a grade that simply doesn't exist in new form at any price. The direction of change is clear. Embodied carbon accounting is becoming standard practice in architecture and construction. LEED certification, the Living Building Challenge, and emerging carbon disclosure requirements from municipal governments are all pushing in the same direction. Account for the carbon cost of your materials. A growing number of cities are adopting whole-life carbon assessments as part of the permitting process. The European Union is moving towards mandatory environmental product declarations for construction materials. Insurance and financing structures are beginning to price in climate risk in ways that favor lower carbon construction. The market is responding. The global architecture salvage history, once fragmented and informal, is professionalizing. Digital platforms are aggregating inventory across salvage yards, making it possible to search material specifications across thousands of sources. Design professionals who develop fluency with reclaimed materials now, who build relationships with salvage suppliers, who learn how to specify in detail for dimensional variability, are positioning themselves ahead of where the industry is going. The practice that once felt niche is becoming the new baseline. Reclaimed materials matter because how we build shapes what we leave behind. Every beam reused is a tree not cut. Every brick salvaged is energy not burned. Every floor reclaimed is a landfill not filled. But it goes further than accounting. When you build with materials that have already had a life, that carry the marks of hands that shaped them, time that weathered them, and use that gave them character, you're making a different kind of object, one that connects the people who will occupy it to something longer than themselves. The best material for the future might be the one that's already had a past. The materials we choose don't just shape how a home looks, they shape how it feels, how it lasts, and even the air inside it. If you enjoyed this video, hit the like button, subscribe, and help us grow a community of people who believe we can build better. In the next video, we're exploring what your walls are breathing into your home and what healthier alternatives might look like. Because when we build better, we breathe better. I'm Terra, and I'll see you in the next one.